Okay, let us discuss problem 1.160. So this says a stationary pulley carries a rope whose one end supports a ladder with a man and other end supports a counterweight of capital mass M. So let us say there is a stationary pulley and this pulley is attached to a roof, and one side of pulley we have a mass capital M. So let us say this side we have a capital mass M. Other side of the pulley, this side you have a ladder attached. So let us say ladder is something like this. So this is the ladder. So let us say this is the ladder we have other side. Now question says there is a man also. So let us say man is here. We'll discuss. So this is the man. And these are static. So this means if the mass of this is M, then this has to be capital M. So mass of this is M and the pulley is in the rest, nothing is moving. Acceleration of the system is 0. So this means if the mass this side is capital M, so this side also it has to be capital M. Now question says the man of mass M climbs up by a distance L dash. So let us say this is the mass of man is M that is given to you, and let us say mass of ladder is M dash. So M dash is mass of ladder. So let us write fast. So this is mass of ladder, and then you have M, that is basically mass of man, that is also given to you. So mass of man is given to you, mass of ladder is given to you. Now question says man moves up by distance L with respect to the ladder. So L is the displacement of man with respect to the ladder. So L is the displacement of man, and this is up. So the man moves up. Displacement of man. This is with respect to ladder. This is also given to you. This is with respect to ladder. So if ladder is going down, then total distance will be not L. With respect to ground, it will have something different. Now question says, neglecting the mass of rope and the friction of pulley axle, find the distance of displacement of center of mass of system. So question says find out displacement of center of mass of the system. So this we have to find out. So how we will proceed? So let me say ladder of, so let us say ladder is initially something like this. Let us say ladder has moment, so center of mass of ladder is somewhere here, and the mass M also lies on the same point. There is the ladder center of mass and mass M coincide. So this is the center of mass of ladder, and the mass M also lies here. So initially I am assuming that the center of mass of ladder is L by 2. So this distance of the total is L by L. Then center of mass of the ladder will lie at a distance L by 2, and I am also saying this person also resting on the center of mass of the ladder. It will not basically change the final result. So I can assume, let us say this is a distance from pulley axis. So initially I will assume the distance from pulley axis, this is x1. Are you getting? So this is the x1 distance of center of mass of ladder plus man system is at a distance of x1. Now let us say this is at a distance of x2. So mass capital M is at a distance of x2. Now what are the relations we have? We will have, since this side and this side is static, that is in the rest, so I must have M plus M dash, it should be equals to M. So this is the first relation I have. Now I can find what is the center of mass of system xcm initially. This will be m1 x1 plus m2 x2 divided by m1 plus m2. Now let us take downward direction as a positive. So my downward direction is positive in this case. So we have m1 x1. So that is this mass and the capital mass and the small m and m dash both lies at distance x1. So I will have m plus m dash into x1 plus m into x2 divided by m plus m dash plus m. And now I also know m plus m dash is basically capital M, so I can plug this value. So it is m x1 plus x2 divided by this is m plus m dash, that is m plus m, so 2m. So this is simply x1 plus x2 by 2. So initially center of mass is lying on a distance x1 plus x2 by 2 from the top. Now the second point is important. Are you getting or not? So what I am saying is, I am saying initially this mass capital M lies at a distance of x2 from the pulley axis. Ladder center of mass lies at a distance of x1 from the pulley axis. I am also saying a small mass m that is in the middle of the ladder, that is at a distance of L by 2. So if this lies in the middle of the ladder, so this means the distance from the pulley axis to the mass man m will also be at a distance of x1. You getting? And now let us discuss if the man moves up by distance L, what will happen in that case. Now let us make the first diagram. If the mass m, the man, moves up by distance L. So how this system will look? So you have, this is the pulley. Now this side you have the ladder. And this side you have mass capital M. Are you getting? Now let us say this man initially was here. Now it moves up by distance L. So now let us say mass is somewhere here. So I can make another. So let us put one more. So let us, mass is somewhere here now. Are you getting? So you can have some dashed ladder. So now this mass is here. Now this mass is here. And the distance that is moved by the mass m in the upward direction is L. Now let us say ladder moves by distance z in the downward direction. What will happen? If the man goes up, this ladder will come down. This mass will go up and this ladder will come down. So let us say this mass goes up by distance z. So if this goes up by distance z, so this length of the thread will be free. So this ladder will come by distance z in the downward direction. Are you getting? So this mass capital M is going up by distance z, and this whole ladder is coming down by distance z. So that is the distance in the downward direction of ladder is z. Now my question is, what is the distance traveled by this man with respect to ground? So very important point we have. What is the distance traveled by man with respect to ground? Distance traveled by man. And this time I am asking, this is with respect to ground. So how will you proceed? And you have to give me the answer. I am waiting for 1 minute. So you see, have you done or not? Let me wait for some more time. Okay, so I can write distance traveled by man with respect to ground. This is equals to distance traveled by man with respect to ladder plus distance traveled by ladder with respect to ground. Are you getting? So if I apply this, distance traveled by man with respect to ground is equals to distance traveled by man with respect to ladder. So man is going up with respect to ladder by distance L, and I have taken upward direction as a negative, so this is minus L. Now distance traveled by ladder with respect to ground. So you see, we have said ground, with respect to ground this ladder is coming downward with distance z. So this will be L minus L plus z. Now what is the x coordinate So what is the coordinate of this time, this mass? Initial coordinate of mass m is x2. You see here. So if you check your copy, this is the distance x2. So now this will be x2 and it has moved up by distance z. So now its coordinate will be x2 minus z because it has moved up by distance z. Now what is the center of mass of ladder? So ladder is center of mass is somewhere here. Initially in the middle. You see the ladder has moved downward by distance z. So center of mass of ladder. So ladder center of mass will be somewhere here. And ladder has moved distance z. Initially ladder of center of mass of ladder was at a distance of x1. So this is the x1 plus z. What is the distance of man from vertical? Initially it was at a position of x1, but now it has moved up. So you see it has gone downward with. So what is the displacement of man you have? So you have displacement of man in the downward direction is this. Because I have taken z downward direction as positive, this is negative. So distance of man, displacement of man with respect to ground in the downward direction is this. So what is the total x coordinate of this man? Initially it was x1. So it was initially x1 and it has gone downward with this displacement z minus l. So now it will be x1 plus z minus l. Are you getting? You try to understand once again. So displacement of man with respect to ground is this. Now initial coordinate of man was x1, the same coordinate you see. Initial coordinate of man was x1. So this is the man coordinate initially, x1. Now man has gone down with respect to ground by a distance of z minus l. So this is z minus l. So what is the total distance by which man has gone in the downward direction? You can see initial was x1. Now what is the coordinate basically? So initial was x1 and it has gone downward direction by z minus l. So the final coordinate you will have x1 plus z minus l. So that I am writing here x1 plus z minus l. Now if I write center of mass again, so xcm will be xcm finally, let us say call this a dash, m1 x1. So mass of this is m and coordinate is x2 minus z. So m into x2 minus z plus mass of the man is m and the coordinate is x1 plus z minus l. So this is m plus m into x1 plus z minus l plus mass of this is mass of the ladder is m dash and the center of mass of the ladder is x1 plus z. So m dash into x1 plus z. I think some of you are able to understand this one. If you are not able to understand, please think again. So this is the center of mass x coordinate and then I have to divide by total mass. That the total mass again m plus m dash plus capital M, that is 2m. Are you getting or not? Total mass will be 2m, m plus m dash, that is equals to capital M, and then you have to add m. So this is 2m. Now let us try to see this one. So what we are getting. So let us take z term of z at one place. So we will have mx2 and there we will have, so this z is one sided, so we will have mx1 here, m into x1 this term and minus m into l, and here we will have m dash into x1, and let us put the z term one side. You will have z, so you will have minus m here. Are you getting? And here you will have plus m, and here you will have plus m dash, and this divided by 2m. So if you basically simplify this equation, you will have this is equals to 0 because m plus m dash is equals to capital M. So m dash plus m is capital M minus capital M. So this is equals to 0. So this term is 0. So I will have mx2, and if I take x1 common, so I will have mx2, and if I take x1 common, so this will be have m plus m dash, that is basically capital M. So this becomes m into x1. Are you getting? Because m plus m dash is capital M minus m into L divided by 2m. Are you getting? And now it is very simple to find what is the difference in initial XCM and the final XCM. So the same thing can be written also in a better way. So we can write, so I can write this same equation. M goes out, so I will have x1 plus x2 by 2 minus ml by 2m. This is the final XCM dash. Initial XCM you can check your copy, that is x1 plus x2 by 2. You see here. So this is x1 plus x2 by 2. So initial XCM is x1 plus x2 by 2. So what is the change? So final minus initial, if I do x dash cm minus xcm, this is, so this goes out, so I will simply have minus ml by 2m. So this is the delta xcm minus ml divided by 2m. So what this minus sign suggests? So minus sign suggests, I assume, the displacement in the downward direction is positive. So this is basically displacement in the upward direction. Are you getting it? So this says me that the center of mass has rose up by distance of ml into ml divided by 2m. So if I want to write, so I can write center of mass has moved up, because minus sign shows me this, the direction is positive in the upward direction, moved up, because I have taken positive in the downward direction. So this is coming negative, this means upward direction. So center of mass has moved up by distance ml divided by 2m, and this is very obvious. So if you have copied this one, then fine, we'll discuss the next problem.